Hi guys, this is Miss Paige and we are going to make a video on 7.1F categories 1 and 2. And let's look at problem 1. Let's see. We're on, page 57, 58, 59, 60, and 61. So let's get this done. Okay. So we put these numbers in order from greatest to least. We're going to make sure that we pay attention to that, greatest to least, because a lot of times it's least to greatest. What we want to do is put these all into the same format so that we can compare them easily. So the first thing that we're going to do is we're going to change 2/3 to a decimal. And all of us should know that 2/3 is the repeating decimal 0.6. So I'm going to put that at least out to 3 places because this one's out to 3 places. So we got 0.666 is 2/3, and we could go on if we wanted to. 50%, to change a percent to a decimal, I'm going to bump that decimal 2 places to the left. So that one's equal to 0.5. Again, I'm going to make sure that it goes out to the thousandths place. And then 3/4, y'all should know, is equal to 0.75. And I'll add a 0 because there's no difference between 0.750 and 0.75. It's still the same thing. I'm just adding a 0 in the next place value. Now I can put these numbers easily in order from least to greatest. So that one was 3/4 and that one was 50%. Okay? So if we just compare the decimals, obviously 875 is going to be the biggest. 750 is the next biggest, 666 is next, and then the 0.5. So it would go like this, 0.875, and then next would be the 3/4, and then next would be the 2/3, and then the smallest, the least, is 50%. Okay? This one, we got 3 1/5, -5.4, 3.15, and -5 and 3/8. Okay, 3 1/5. Again, I'm going to do the same thing. I'm going to make sure that everything has a decimal number so that it's easy to compare these. And we've already got the 1 or 2 of them that are in decimal form, but we also have negatives now. So they've added a little bit more fun to the mix. So I'm going to divide this to show that that goes up there. Okay, so first of all, 3 1/5, if I write that as a decimal, is going to be 3.2. I'm going to go to the hundredths place this time, so 3.20. The next one, -5.4, -5.4, I'm going to add a 0, 3.15, and then -5 and 3/8. So -5 and 3/8 as a decimal is 375. In order to change that, I would divide that 3 divided by 8, and that's going to go 0.375 when you divide that out. Okay, the reason why I knew that it was 0.375 without working it out is because I know that 1/8 is 0.125, so I just multiplied it times 3. So I'm going to add zeros here so that everything goes out to the same place value and it's easy to compare. Remember, whenever you're looking at this on a number line, -5.4 would be further to the left on the number line. So that's going to be our smallest one. So that's the least. And then the biggest one is going to be this 3.2. It's going to be furthest to the right on the number line. So that's the greatest, and then we'll just put them in order from there. So 3.2 is the same thing as 3 1/5, and then next would be the 3.15, and then after that we have -5 and 3/8, so that's what that's equivalent to. And then the last one would be -5.1. Okay, so now we've got that one put in order from greatest to least. Okay, the next one, they want us to put these in order from least to greatest, so the opposite direction. Negative 8 is going to be the furthest to the left on the number line, so it is our least. And if we're going towards our greatest, let's see, we've got that one. And then next would be this negative 1 1/3. And then the negative 3/5, because that's less than 1. And then the 0. And then 3.5. And then 4. Okay, so that's the numbers in order from least to greatest. If you put them on a number line, this is the order that they would be in on that number line. Problem 3, they want us to write the probability so that the pair of numbers represents the probability of an event occurring and the probability of the complement of the event. So 20% and its complement would be 80%. Okay, a 20% of something occurring and 80% chance that it would not occur. 0.32 is in the decimal form for the probability of an event. In order for us to figure out its complement, you would just, like here, we did 100 minus 20. And that equals, this is all percents, 100% minus 20% equals 80%. Here we have 1.0 minus 0.32. That equals 0.68. So if we leave this in this decimal form, 0.68 is the complement, or the chances that this event would not happen. 7 out of 8 chance that it is going to happen. The complement of that, if I take 8 out of 8, or 1 whole, and I subtract 7/8 from that, that gives me a 1/8 chance that it would not happen. So that's the complement, 1/8. Problem 4, a qualitative prediction. Can use these phrases. We got less likely, impossible, equally likely, more likely, or certain. Okay, so less likely is, or unlikely is what we usually use. That is a greater than 0% chance that something's going to happen, but it's also a less than 50% chance that it's going to happen. An impossible thing is a 0% chance that it's going to happen. Equally likely means that there is a 50% chance that it's going to happen. There's a 50% chance that it will happen, 50% chance that it will not happen. More likely, we just call that likely, is going to be greater than 50%, but less than 100% chance that something's going to happen. And then certain is 100% chance of an event occurring. So the probability that you're going to roll a 7 on a number cube, well, there's not a 7, so that's a 0% chance. So we're going to say that that's impossible. The probability of rolling an even number on a 1 through 6 number cube, well, there's 3 even numbers and there's 3 odd numbers, so that one's equally likely. And another way you hear that phrased is as likely as not. Another one, the probability of rolling a 5 on a 1 through 6 number cube. So that's a 1 out of 6 chance. That's pretty unlikely, so we're going to put less likely, or unlikely is fine. The probability of tossing a head on a penny. So one side is heads, one side is tails. It's a 50% chance that that's going to happen. So we're going to put equally likely again. And the probability of tossing a head or a tail on a penny. You're either going to get a head or a tail. That's a 100% chance that that's going to happen. So we're going to put that that is certain. And then this last one, the probability of rolling a number larger than a 2 on a 1 through 6 number cube. So you got 3, 4, 5, or 6. So you got 4 out of 6. That's more than half, so that's pretty likely that that's going to happen. So we're going to put more likely. There, and those are qualitative predictions. In other words, that's the word description of how likely something is. A lot of times we do this quantitative predictions, but sometimes we got to just use our words, so qualitative. All right, for problem 5, you toss a coin 6 times and you get 4 tails and 2 tails. You spin a spinner with 5 equal parts labeled 1, 2, 3, 4, 5. After 6 spins, you spun a 1, 2 2s, 2 3s, and a 6. Which of the following do you predict is more likely to happen if you repeat the process again? Circle your choice. So, I think that this was probably a misprint, and it should say 4 tails and 2 heads. And if we go with that, then you're going to toss 4 tails and 1 head, and you're going to spin a number less than 5 each time. Okay, so this one actually is pretty likely because this is 4 tails and 1 of these 2 heads, so that would work. That's probably going to happen again. But this one, spinning a number less than a 5 each time, that's also pretty likely to happen. So, let's see. Spin a 1, 2 2s, 2 3s, and a 4. Yeah, that one's likely too. Maybe I wasn't supposed to change it, and then that one would be impossible. I don't know. Anyway, they're both pretty likely to happen as long as we change that. Problem 6, when rolling a 1 through 6 number cube, the table below shows the possible products for the 2 numbers that were rolled. So we have basically a multiplication table here. And if Andrew rolled 2 number cubes, what's the probability that he's going to have a product that's larger than 20? So if we go through here and we identify all of the numbers that are larger than 20, not 20 itself, but any number that's larger than 20, that gives us all of these numbers here. So there's 1, 2, 3, 4, 5, 6 numbers that are larger than 20. So that would be 6 out of, if you count all of these outcomes, there are 36 outcomes. Okay, 6 times 6 is 36. So the probability of an outcome that is greater than 20, there's 6 favorable outcomes, and there are 36 possible outcomes. So if I reduce that, that's 1 out of 6. So there's a 1/6 chance of that happening. Now, if Andrew rolls 2 number cubes 50 times, how many times should he expect to roll 2 numbers whose product is larger than 20? So if that happens 1 out of 6 times, then we can get our prediction by setting up a proportion and putting that over 50. So if we cross multiply and divide this, 1 times 50 is just 50 divided by 6 is going to give us our answer. So 50 divided by 6, I know that 6 times 9 is 54, 6 times 8 is 48 with a 2 remainder. So it does say about how many. So we're going to say about, even though this didn't go exactly evenly, 8 times. It's 8 point something. Is it likely that he's going to roll 2 numbers whose product is larger than 20 15 times during those 50 rolls? No. We're expecting to see it about 8 times, so we're going to put no. That is unlikely, because that's nearly twice as many times as we're looking to see it. We're planning on about 8 times. Okay. Problem 7. At a conference, the management placed 10 door prize certificates randomly under the seats of the 200 chairs the audience will sit in. If Miss Barrera is attending the conference, what is the probability that she's going to choose a chair with a door prize certificate? So there's 10 door prizes and there's 200 chairs. So the probability of a door prize, so let's put DP, not Dr. Pepper, darn, 10 out of 200. And we can reduce that by canceling these zeros. So there's only a 1 out of 20 chance that she's going to get one of the door prizes. Is it likely that she's going to get a door prize? Well, no. She might, but she would have to be the 1 out of 20 people that got it. So it's not very likely. 1 out of 20 is a 5% chance. It's not very likely. Draw a tree diagram that shows the outcome for tossing a penny and spinning a spinner with 4 equal parts colored red, blue, green, and yellow. So, for the penny, you can get heads and you can get tails. And when you spin the spinner, you can get red, you can get blue, you can get green, and you can get yellow. Red, blue, green, and yellow. Okay, there you go. Did a tree diagram. Good job, self. Next, we're moving on to student activities for category 2. For problem 1, it says the table below shows the relationship between ounces and pounds. So 16 ounces is a pound, 32 is 2 pounds, 64 4 ounces, blah, 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 blah. So it's asking us for the constant of proportionality. Remember, constant is equal to your y value divided by your x value. So if I divide this, 1 divided by 16 is equal to 2 divided by 32, and 4 divided by 64, and so on. So our constant is equal to 1 over 16 if we reduce it all the way. Okay? So it asks us to write an equation that represents the relationship between x and y. And if you look at your math chart, it tells you that y is equal to the constant times your x value. So if I substitute in 1/16 for k, y is equal to 1/16 of x. And that's our equation. The next one, a bag of marbles is shown below, and it asks us for the ratio of white to blue marbles. So if I count my white marbles, I've got 1, 2, 3. And if I count my blue marbles, 1, 2, 3, 4. So it's a 3 to 4 ratio. You'll see that written as a fraction, and you'll also see it written this way. So those are the 3 different ways to write a ratio. If the ratio remains the same, how many white marbles are in a bag with 77 marbles? So if we take this ratio of 3 white to 4 blue, and we make it into a proportion where we have white marbles never mind, we're going to say there's 3 white marbles in this bag that has 7 marbles. Sorry. How many white marbles are there going to be when there are 77 marbles in the bag? Y'all see where I got that 7? I got that from adding all of the marbles together, and there are 1, 2, 3, 4, 5, 6, 7 marbles all together in the bag. Okay? So, if I cross multiply and divide this, 77 times 3 divided by 7. Cross multiply, divide by the lonely guy. So 77 times 3 divided by 7. I know that 7 goes into 77 11 times, and 7 goes into 7 1 time. So my answer is x is equal to 11 times 3, which is 33 white marbles. So we would expect 33 white marbles to be in the bag. Okay. The next one, the ratio of red parts to blue parts in a flag is a 3:2 ratio. How many of the parts below would be red if they represented the parts of the flag? So what we could do is you could do red, 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 blue, blue. This is red to blue, so 3 red to every 2 blue. And then red, 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 blue, blue. And then red, 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 blue, blue. Red, 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 blue, blue. Okay? And if I count this all out, I find how many of the parts would be red. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 red parts. I could have set up a proportion and counted all of this, and there's 20 of these, and then I could have solved the proportion and figured it out that way, or just use the picture to draw it. That was fine too. Moving on, problem 4. Ms. Brown made 9½ cups of stewed tomatoes. She's freezing the stewed tomatoes in half-cup containers to use in soups and casseroles later. To determine the number of containers that she needs to divide 9.5 by 0.5. What's the value of 9.5 divided by 0.5? So if I have 9.5 and I divide that by 0.5, you'll need to remember that we can't divide by a number that has a decimal in it, so we have to bump it over 1. But if we bump it over 1 in the divisor, we have to bump it over 1 in the dividend. So 5 goes into 95, 1 time there, put a 5 and a 40, bring down your 5. 5 goes into 45 9 times, and that's it. It goes evenly 19 times, and we showed our work. All right, problem 5. Mr. Shelton bought 6 packages of ground beef. Each package was 1½ pounds. Write an expression to represent the total weight of the beef. So 6 packages times 1½ pounds equals the weight. Simplify the expression to find the number of pounds of ground beef that she bought. Well, 6 times 1½ if I multiply that out, it gives me 9 pounds of beef. 9 pounds. All right. Problem 6. Analyze the table below. What is the constant of proportionality shown in the table? So it's letting us know that there is a constant of proportionality, and constant of proportionality is your y value divided by your x values. 24 divided by 3 is 8. 40 y divided by 5, my x, is 8. 64 divided by 8 is 8. You see how we get the same answer each time, because it is a constant of proportionality. It's a constant relationship. It does not change. And then they want us to write this equation that represents the data in the table. If you look at your math chart tells you this equation. It's y is equal to the constant of proportionality times whatever x is. So y is equal to my constant 8 times x. Next one, look at the graph below. It represents the length and the width of a rectangle. What is the constant rate of change shown in the table? If the width is 12 units, what would be the length? Okay, so rate of change. Remember from earlier in the year we talked about rate of change, and we said that's the change in y divided by my change in x. It also is our slope. Okay, that's another word that you will see. So, and even more, to develop this even more, that's your rise over your run. So the constant rate of change, if I pick 2 points that goes through the, that's on the crosshairs here, okay, there's one there at the point 312. And then we know there's one at 0, 0. Okay, so if I if I rise 12 and I run 3, that means that my slope is 4. Okay? My constant rate of change is 4. If the width is 12 units, what's the length going to be? It represents the length and the width of the, okay. So the length is going to be 3. Okay. Oh, I'm sorry. This has width right here, so that is not true. If it was the other way around, if the length was 12, then the width would be 3. But this is telling you that the width is 12. So if you'll notice that the constant is multiplying by this rate of change, so we could just say 12 times 4, and that gives us 48. Okay? So the length would be 48 when the width was 12. Sorry, I was reading that backwards. So width and length. Alright, guys. Last page. Problem 8. Complete the table below to show a constant rate of change of 1/2. So, half of, let's see, if y is equal to my constant times x, 18 is equal to 1/2 of what number? Half of 36 is 18. Honora, get down from there. So that means that that's my relationship. So x is half of y. So half of 5 is 2.5. Half of 8 is 4. Half of 160 is 80. There we go. Okay? Think about it this way, rate of change. So if my rate of change is my change in y divided by my change in x, just to prove this, 4 to 80 is a change of 76. And my change in x here, from 8 to 160, that's a change of 152. Well, this is the same thing as 1/2, because 76 is half of 152. So it works. Okay? Alright, the next one. On the coordinate grid below, graph this equation. Y is equal to 3 times x plus 1. Remember two things when you're graphing. One is in the format y equals mx plus b. M is my slope. So my slope is 3. So whenever I rise over run, I'm going to rise 3 and I'm going to run 1 whenever I'm graphing that slope. And then the point where I start is at that y-intercept. Okay? That's also known as my starting point. So the y-intercept is 1, so that means that x is 0 and y is 1 at that starting point. Okay? So if I rise 3 and I run 1 from there, rise 3, run 1, there we go. Okay? And that is what my line looks like. And that is the graph of y is equal to 3x plus 1. Okay? The next one, the point 63 belongs to a line graph, and the line has a slope of 2/3. Explain how you can use the slope to locate a second point on the line. So we know that we rise 2 and we run 3. And this is my x, and this is my y. So if I change my y value by going up 2, I can add 2 to that. And if I run 3, that means I can go into the right 3. I can add 3 to whatever my x is. So I can get another point at 9, 5 just by using x and y. Okay? So another point on the line would be 9, 5. Another point, because my slope is 2/3. Let's see. Let me just stop right there at my explanation. Explain how to use the slope to locate. Okay. And let's move on to the next one. Write a real-world problem to correspond to this equation. 2 times x plus 3 equals 11. Okay. I could just say 2 times a number increased by 3 is 11. And there we go. And the next one, decide if the given value makes the equation or inequality true, yes or no. Okay, so 6, if we put this in here, we're substituting it in for that x. 2 times 6 plus 1 is 13, right? Is 13 less than 10? No. Okay. So 13 is not less than 10, so I'm going to cross that off. What about the next one? 3. I'm going to put this in there, times negative 2 plus 2 equals negative 4. So if I solve this, 3 times negative 2 is negative 6. And if I add positive 2 to negative 6, I get negative 4. And that does equal negative 4. So we're going to put yes there. Okay? So that is all of your student activities for pages 56 through 61. I hope that this helped you, or 57 through 61, sorry. Hope that this helped you to understand these topics. And if you have any questions, ask your teachers. And have a great day, guys. Bye.